We're solving problem 6 from the 2019 AMC12A. The figure below shows line L with a regular infinite recurring pattern of squares and line segments. How many of the following 4 kinds of rigid motion transformations of the plane in which this figure is drawn, other than the identity transformation, will transform this figure onto itself? Some point around a line, some rotation around a point of line L, some translation in the direction parallel to line L, the reflection across line L, or some reflection across a line perpendicular to line L. Let's just start with the first one. If we do a rotation around on the point of line L, about like right here, say in between these two squares, or these two figures, and rotate it 100 degrees, 180 degrees, then it would map itself, these two squares would map onto itself, assuming, it's literally the same measurement, so it would indeed map onto itself, so this one is correct. Now, some translation in the direction parallel to line L, so that means it's basically either going this way or this way, and yes, this would work if there was a translation of the length that would get this point to this point, or vice versa. So this one works. And the reflection across line L. Well, if we reflect all these squares over line L, it would be offset, and these diagonal lines would be facing the incorrect direction, so this one does not work. And finally, we have some reflection across a line perpendicular to line L. So no matter what we try, basically, if we stick a perpendicular line here, all the cubes are again going to be offset because the diagonal lines are facing the wrong way. So this one's incorrect. So we only have 2 correct statements, and that is our answer for this problem.